Hello everyone, welcoming you to another video on advanced game theory. So, this is the question with which I had stopped in the last video, that how can we have an equilibrium division of resources of the society such that it is agreeable to all possible groups of the society, right? And I have mentioned that to answer this question, we already have very famous two solutions that have been proposed. The first one is defined as the core of the solution, core of the cooperative game, sorry. And the second one is what we call it as the Shapley value of a cooperative game. Now, we will be coming to this one by one. And in this video, I'm going to talk of what essentially is known as the core of a cooperative game. Core of a cooperative game. This is what we are going to look at. Now, before actually defining that what exactly it is, I have a few more concepts in hand that will help us to understand core better. Now, what essentially is the idea of a core? So, we basically want to find out a payoff vector or a set of payoff vectors which will be actually be which will be suggesting a agreeable division of the resources, right? So we want to find out a set of payoff vectors. This is very important. We want to find out a set of payoff vectors. And how does a payoff vector look like? It is, if I write it in general, x of a1 dot dot x of an. We want to find a set of payoff vectors because it is possible that there might be many possible payoff vectors which is agreeable to all the people in the society, right? So that is why we are broadly we are considering as it as a set of payoff vectors. We want to find out a set of payoff vectors that is agreeable to all groups. This is agreeable to all groups in the society. This is the ultimate target that we are going to all groups of the society. Now, essentially, if I have to just mention a small difference between these two solution concepts, that is the core and the Shapley value, usually what happens is that core can give us multiple solutions, multiple possible divisions, as I will say. That is why in the beginning only I am mentioning it as a set. And Shapley value, if it exists, will always give me a unique solution. That means it is basically telling that you will have one particular split of the resources that will satisfy certain conditions. So essentially you can understand that if I have to get a multiple solutions case for a core and a unique value for a Shapley equilibrium, that there will be certain conditions which will be different, right? That will lead to different kind of cases. So that is where comes the idea of framing certain conditions. So essentially I want to find out a set of vectors which we can call it as a core of a cooperative game. And the core is what? It is some kind of a solution concept which will satisfy certain conditions. Individual intuitively appealing conditions. Okay, now what do I mean by them? So essentially we want to find out, let me just write that out once more. We want to obtain the core of the cooperative game. Which is denoted as P of V, core of the game. Now before actually defining the core, let me just go over two small concepts and that will be making it easier for us to understand this better. Number one, what we call it as individual rationality. What do I mean by this? So all these properties you have to understand are mentioned with respect to a payoff vector, because a payoff vector should satisfy certain conditions and that will eventually lead to that payoff vector qualifying to be in a core. So the first condition is that individual rationality. So what do I mean by this? If I just write it down, a payoff vector is individually rational if the payoff that it gets under the grand coalition is greater than equals to at least its worth, and this condition has to be satisfied for all the players in the society. This will make a particular payoff vector individually rational. Pretty intuitive, right? Because if alone only, if you are not getting how much you would have got independently, then obviously it is not rational for you to participate. So this is the condition that the payoff vector must satisfy for all the players if it wants the grand coalition to occur, and this particular payoff vector should qualify as a core of the cooperative game. The second one is Pareto Optimality. Now this is essentially coming directly from my concept of microeconomics. That means the total output should be divided completely. There should be no surplus which is left over. Therefore, a payoff vector is Pareto optimal if the worth of the grand coalition is exactly equals to the summation of x of ai for all ai belonging to n. And this thing often I will be referring to it as x of n. Okay. So this is the condition of Pareto optimality coming out directly from the microeconomic concept of complete distribution of resources or full employment structure. So essentially just running a note that I want to mention over here. That means for any coalition, for any coalition for any coalition S, for any coalition S which is a subset of N, and S is not equals to phi, what will happen for any coalition S? The payoff from participating in the grand coalition, will be participating in the grand coalition will be summation, just a moment, let me just write it a little bit more clearly, summation for all over all the players who belong to that particular coalition, which is x of ai, and that is what I am going to term it as x of s. Okay, so now these are the two very economically intuitive conditions that we have over here that the payoff vector should satisfy. The first one is known as individual rationality, and the second one is known as the the Pareto optimality. So if you have a particular, so now with these two things in hand right now, we can define something which is known as the set of imputations, which is denoted as IV. What is the set of imputation? It is basically referring to all those payoff vectors that satisfy individual rationality and Pareto optimality. It is basically set of all those payoff vectors that satisfy individual rationality. I'm just writing it in short. Individual rationality and Pareto optimality. Pareto optimality. Therefore, how can we define the set of imputations? It is a set of all payoff vectors. I'm just putting a general notation. That means considering a n player society, x of an, such that x of ai, the individual rationality part, is should be greater than equals to v of ai for all ai belonging to n, the individual rationality part, and xn should be equals to vn. Okay, so this is the set of imputations. Now coming to the core. How can we define the core with all these two things in hand? Now core is basically, it is a set of payoff vectors that are in imputation IV. That means they satisfy already individual rationality and Pareto optimality that are present in IV and are not blocked by any possible coalition. That means all possible coalitions in the society agree to that particular payoff. Therefore, what do I mean if I just write it down? So what will be the core by definition? It is a set of all payoff vectors xa1 dot 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 xan which belong to imputation IV, that is why I've mentioned this set before, such that the the payoff of the coalition that they will get under the grand coalition should be at least greater than equals to the worth for all S, which is a subset of S, N, and S should not be equals to phi. This is essentially what we call it as the core of a cooperative game. Okay. So that is why I have mentioned, defined the set of imputations before, and then comes the definition of core. Okay. So now we have understood. So basically the core satisfies three main properties. One, the payoff vectors belonging to core are individually rational. They are Pareto optimal. And finally, they are not blocked by any possible coalition. And when will they not be blocked? The total payoff that they get from the grand coalition, which is excess, should be at least greater than equals to Vs for all possible subsets which are non-empty. So with this, we understand that how exactly a core is defined. In the next video, I will set up a real life example of a game, and then we will set how we can calculate the core of that game. Thank you.